Isolated pulsars, or non-accreting pulsars in a binary system, are found in a rotation-powered state, in which they spin down due to the magnetic dipole emission. The non-thermal processes in their magnetosphere allow their detection in the radio and gamma ray bands. In binary systems, pulsar can accrete matter from the evolved companion star. When the matter overflows the inner Lagrangian point, it is pulled towards the pulsar, forming an accretion disk. Accretion eventually occurs at the polar caps, giving rise to X-ray pulsed emission. The pulsar undergoes a process of spin-up. According to the recycling scenario, all the pulsars in binary systems can reach spin periods of around 1 millisecond, through several spin-up processes. Transitional millisecond pulsars are a direct evidence of this model. Transitional millisecond pulsars are defined as millisecond pulsars that switch between rotation and accretion-powered state. Currently, there are only 3 confirmed transitional pulsars, of which only one was observed in both rotation and accretion-powered state. The remaining 2 showed a third X-ray active state, called subluminous state, due to its characteristic faint luminosity. In the subluminous state, a disk is present in the system, but the pulsar is not accreting. Typical characteristics of the state are a bimodal X-ray light curve, pulsed emission spanning from the optical to the X-ray, and enhanced gamma ray emission. They are all thought to arise from synchrotron emission happening at the inner rim of the disk, where the pulsar wind interacts with the matter, creating a shock. In this work, we study the candidate transitional pulsar J1109 to search for a gamma ray counterpart to the known Chandra X-ray source. We analyze about 15 years of Fermilab data, with the advantage of 3 more years with respect to the latest Fermilab catalog, which did not find a compatible localization to the X-ray source. We model the gamma ray background emission, consisting of around 180 point sources, plus the galactic diffuse and isotropic components. In this way, we extract spectral information about our source, otherwise submerged by the emission of the neighboring sources. We model our source emission with a power law with index 2.5 and obtain a test statistic value of around 40. Our new localization is compatible with the X-ray source within the 95% confidence level. The compatible localization of the gamma ray source with the X-ray source is one step closer to the identification of J1109 as a transitional pulsar. Keeping in mind the uncertainty on the distance of the source, we can say that J1109 is either one of the faintest or one of the farthest candidate transitional pulsars.